Here is an example of amide hydrolysis. We're going to do both the acid hydrolysis and the base hydrolysis of the following amide. Notice this is an amide because we have a carbonyl bonded to a nitrogen, and this nitrogen has 3 bonds around it, and the carbonyl has some sort of an R group attached. You'll also remember that the nitrogen also has a lone pair. When we do a hydrolysis, we're going to add water. Now I'm going to show the water as just the acid being in aqueous solution. So we could write this in a couple of different ways. We could write it as HCl and AQ, which means there's water, or we could write it as plus H2O in the presence of HCl. Most of the time I'm going to write it in this lower fashion, so this would be just another option. But this is the main way that it'll be written. So we're going to take the amide, we're going to react it with aqueous acid, which means there's plenty of acid and plenty of water. What's going to happen when we do this hydrolysis is that we are going to break a bond. The bond that we're going to break is the amide bond, which is the bond between the carbonyl and the nitrogen. So that bond is this one right here. So what will happen is from the water that's present, we're going to get the OH going on to the carbonyl, and we're going to get the H going on to the amine. So the result will be that we get a carboxylic acid with the same carbon chain as before, and we're going to get the amine. So we had the nitrogen with the 2 methyl groups on it, a lone pair, and bonded to the carbonyl. Now instead of being bonded to the carbonyl, it's going to be bonded to the H. Now what we have to look at anytime we do an amide hydrolysis is what is the acid or base characteristics of the solution. In this case, the reaction is happening in acid, so that means that the amine is going to react with the acid, and we will no longer have the amine. What we will have is an additional hydrogen attached to there. So what we will have is something like this. So we will form the ammonium ion, and in this case we're making dimethylammonium as well as our benzoic acid. Along with this dimethylammonium ion, in order to keep the charge balanced, we can write the Cl-. So when we hydrolyze an amide in acid solution, we're going to get a carboxylic acid and an ammonium ion along with the chloride counterion. Now let's do the same hydrolysis but using base. So I'm going to write this as adding NaOH and in aqueous solution. So there's plenty of base, plenty of water. We're going to break the same bond right there, and what we're going to end up with is we're going to end up with our carboxylic acid and we're going to end up with the amine. So where the nitrogen was bonded to the carbonyl, it's now going to be bonded to the H. With any amide hydrolysis, we need to consider if the reaction is taking place in acidic or basic solution. And since it's taking place in basic solution, and we have an acid as our product, this acid is going to donate an H+ to the base, and so we will no longer have the carboxylic acid. What we will have is a carboxylate anion, and it'll be balanced out by the sodium cation. So when we hydrolyze an amide, Using basic solution, what we're going to produce is a carboxylate ion and the amine. The amine will remain uncharged because it's in base. Amines are bases, so in base it remains as an amine.